evacuated glass envelope that contains two essential items, the cathode emitter and the anode target. A large potential difference of typically 100,000 volts is maintained between the anode and the cathode. The cathode emitter is a piece of metal that is heated by a low voltage supply. Electrons are liberated at the cathode by thermionic emission and are accelerated in the electric field between the anode and the cathode towards the target. The cathode is shaped to focus the electrons onto a small portion of the target, which increases the intensity of the X-rays produced. The target is typically a piece of tungsten or molybdenum, which may be embedded in a stationary water or oil-cooled rod or on a rotating disc. The high-speed electrons collide with the target and rapidly lose energy. There are two X-ray producing interactions between the incident electrons and the atoms in the target. In the first, electrons are scattered by electrostatic interaction with the nuclei of the target material. This results in the direct emission of X-rays from the electron as it loses energy. This process is called Bremsstrahlung, from the German meaning break-in radiation. Bremsstrahlung radiation has a continuous spectrum corresponding to electrons losing different fractions of their initial kinetic energy. When the electron loses a small amount of energy, a long wavelength X-ray is produced. When it loses a larger amount of energy, shorter wavelength X-rays are produced. The spectrum has a minimum wavelength below which X-rays are not produced. This corresponds to the highest energy X-rays which are produced when the electron loses all its kinetic energy. The second interaction that can take place in the target is between the incoming electrons and the electrons of the target atoms. If the incident electron has certain characteristic energies, it can eject electrons from the inner shells of the target atoms. These are filled when outer shell electrons make transitions to fill in the inner shell vacancies. These transitions reduce the energy state of the atom by emitting X-rays with characteristic wavelengths. These characteristic spikes are superimposed on the continuous Bremsstrahlung spectrum to give the X-ray spectrum observed by experiment. If we change this plot to show the number of X-ray photons versus photon energy, we see that the basic shape is reversed, with a continuum that rises from low energy to a peak, then falls to zero at the point where the maximum X-ray energy is achieved. The characteristic spikes due to target atom inner shell interactions are also still evident. If the potential difference between the anode and cathode is increased, the electrons will gain more energy prior to collision with the target, and both the height of the peaks and the highest possible energy of the X-rays will increase. The target anode is angled to ensure that the X-rays are directed through a window in the desired direction.
The computer era has brought us a dental technology called digital radiography. With this technology, we use computerized equipment and software
You should begin each day with a startup review. First, check the chemistry in the fixer and developer replenishment bottles. If there is 1 inch or less of chemistry, change these bottles. For best results, we suggest replacing the replenishment bottles every 2 weeks, even if there is chemistry remaining. You should never use the last 1 inch of chemistry, as chemistry oxidizes over time and becomes depleted. Now turn on the main water supply and the power switch. When the power switch is turned on, power, temperature, and normal speed indicator lights illuminate. In 15 to 35 minutes, the ready light illuminates. The temperature displayed should read 82 degrees Fahrenheit, the factory set point. Before processing, run a new cleaning film at normal speed to pick up any deposits that may have formed on the rollers. During the day, run a new cleaning film if no films are processed for 2 or more hours. It's important to always use a new cleaning film. Never wash and reuse a cleaning film. Your AT2000XR is automatically set for normal speed. This 5.5-minute cycle is ideal for all cephalometric, panoramic, and intraoral films for optimum density and archival quality. The 2.5-minute endo speed is only for number 2 size films, used for endodontic and other procedures not requiring archival quality. To activate endo speed, press the keypad when the processor is in standby mode. That's when the processing light is off. When activated, the endo speed indicator light flashes as a reminder that the processor is set to this speed. Please note that only one number 2 film can be processed at a time while in this mode. When a film is inserted, processing starts automatically. Wait until the processing light stops flashing before inserting the next film. When processing intraoral films, insert them lengthwise and straight with the marker point entering last. To prevent overlapping, start with tracks 1, 3, 5. Then use 2, 4, 6. The films are processed and then exit in the same sequence.
There are three options for taking bite wings. The first is the XCP, or Extension Cone Paralleling Device. The bite wing XCP consists of three components: the bite block, the ring, and the indicator arm. The bite block, or receptor, holds the SP plate or film in place. The aiming ring helps to align the X-ray beam to the bite block. Holding both of these components together is the indicator arm, which connects the holder to the aligning ring and establishes vertical and horizontal beam geometry.
To assemble the bite wing XCP holder, we take the indicator arm, we slide the aiming ring with the ring facing the same direction as the prongs. We take the receptor holder and we slide it into the pins. We make sure that where the film is going to be positioned is away from the rings. In order to place the plate, we make sure the smooth side is facing the aiming ring.
When checking your assembly, make sure you can see the smooth side of the plate centered.
We're taking a posterior bite wing. We're going to put this in our patient's mouth and we're going to place it far enough back, and our patient is going to bite on the bite block part. And we want to make sure that we get the contact of the distal of the 5 and the mesial of the 6. So we want to place this so that we're going to have the edge of the X-ray coming almost to the mesial of the 5, and we're going to get our patient to bite together, and we're going to slide the ring in. Then again, we'll take our PID and we're going to line it up so that we're parallel with the ring and take the X-ray.